Good morning, good evening, wherever you are. I'm really excited to be back again, and we have Koushik and Siva with us today. And the topic that we are going to talk about today is microservices. Really excited to talk about microservices, Koushik and Siva.
It's a
Yeah,
hot
thank you
topic.
for having us.
Yeah.
One of the things that we want to start off today with is the new podcast Koushik started. Koushik, do you want to start talk about that?
Yeah, no, absolutely. So I thought I'd give this a try. I've been toying with the idea of making a podcast for quite a bit. And I had one of the conversations I had was with Ranga. We had a phone call where we were talking about a bunch of ideas, and this was one of the things that came up. So that was one of the inspirations for me to start a podcast. So I have a podcast called The Artifact. There is a website for it, which is theartifact.io. No spaces or symbols or dashes or anything. It's just theartifact.io. It is an attempt at exploring certain topics in a lot more detail, as well as talking to others who are experts in the industry or they have significant knowledge of certain topics. The very first episode was with Mr. Ranga over here. He graciously accepted to be a guest, and we've had a really fun conversation, and an interesting conversation as well. So I hope everybody listening to this video or audio, check out the artifact.io and check out the podcast episodes that are available out there. And there are more coming soon. I plan to have one show a week. And every show, I hope, is going to teach you something that you didn't already know, at least one thing that you already didn't know. So do check it out.
Glad to hear that you are starting a podcast, Kaushik. And it was a privilege actually to be the first guest on there. I hear a lot of podcasts, so I now have one more to listen to every week. Shiva, any interesting projects that you are working on?
Nothing. No. But I want to appreciate Kaushik for that podcast. I watched a couple of videos, and one with Ranga, and a lot of interesting discussions around so many technical topics, and also other podcast. Second episode, I guess. I get to know a lot of updates on tech community. What is happening? Is there anything new? So if anybody wants to know what is happening in the community, I guess that's a wonderful source of information that you can get from Artifact. I strongly suggest you to follow.
Absolutely.
Thank you.
So if you are like me, calling Java EE as Java EE, and you want to stop doing that, go ahead and listen to the podcast. Okay. So let's probably switch over to the topic of the day, microservices. Uh, Microservices came in with a lot of promise. You'd be able to release faster, you'll be able to innovate faster, and it's almost like 5 years, 6 years since the time microservices became really, really popular. So the objective of our discussion today is not to discuss what is microservice. If you want to find that out, probably you can just do a search for microservices Java Brain or microservices in 28 minutes, and you'd see tons of content right there on microservices. The goal is to discuss the evolution of microservices in the last few years. Have we really realized the benefits which were promised by microservices? And also to discuss some of the things which are happening in the industry today: containers, container orchestration, serverless, and how they are impacting the microservices architectures. So that's what we'll be discussing today. Shiva, shall we start with a high level overview of, did microservices really deliver on the promise?
I have a slightly different opinion about microservices. When most of the people start talking about microservices, they go, okay, it's independently you can deploy, it's a service boundary, those things. But I have a different opinion. Like, it is not really addressing a technical concern. It is more around dealing with a business scalability issue. It is, say, let's take a large organization. There are as a business, you are trying to deliver a product, but there are a lot of teams working towards delivering that product. But as the number of people, number of teams are increasing, it's hard to coordinate and it's hard to synchronize the efforts going on across the teams. So let's take, for example, there is a single monolithic repository, and the number of people increases, the number of peers, number of match conflicts, and all those things increases. That's one problem. Another thing is when you have a monolithic application, and if you want to scale up a subset of the components, you can't do that in a monolithic application. And also, from the organization point of view, not all the departments move in the same pace, right? Some departments they can move forward quickly, but some of the teams they move a little slower, depending on how complex their business processes are. So coordinating all of those teams in a single deliverable manner, it's really complex. So that is main reason I believe the microservices concept came in, where you split it apart based on the business domains and let them evolve in their own pace, and then try to achieve the overall organization goal. So for me, it is microservices more like tackling the organization growth. I mean, the complexity of number of teams, team size. But as a byproduct, you get a lot of technical benefits as well. But I have few concerns over there also. When I look at many projects that implemented microservices, it's not many of them are doing really good. Very few are really successful delivering the promises of microservices. But most of the other applications they end up as distributed monolithics. One component goes down, nothing is working fine. So that shouldn't be the case in the first place. That is the very first promise microservice talk about. But it is not the fault of microservice concept per se. It is how people understand it and how they implement it. I have a mixed opinion about adopting microservices.
Very interesting, Shiva. Kaushik?
I agree with the driver behind microservices. I think it was Martin Fowler who said that you have to be this tall to use microservices. Kind of drawing an analogy to the theme park rides, right? So you have to be of a certain height to get into the ride. If you're shorter than that, you're not ready to do that. So I think there is a certain entry criteria for microservices as well. As long as that entry criteria is met, in this case, like what Shiva was mentioning, there is a certain organizational maturity that's needed to adopt microservices. There is a certain level of complexity in the organization, the code base, that need to be present, and the team is dealing with and struggling with, for the team to say, well, yeah, we're going to go with microservices. Because again, there is a cost to be paid for adopting microservices. And the question is it worth what you're going to get back? For some organizations, the answer is no. But has it prevented people from going the microservices route? No. People still find that to be buzzworthy and they get into it. And a lot of, to answer the question, has microservices fulfilled its promise? The answer is, if the people adopting microservices have known the true promise and known the cost and the payoff of microservices and then adopted it, and they did microservices well, then yes, it has fulfilled the promise. However, if there are two problems: one, the company is not ready for microservices or not mature enough for microservices and they still adopted it, or two, the company is mature enough for microservices but they adopted microservices badly, or third option, which is both of them, which is like the worst possible situation. In those
Yeah,
three cases, the microservices architecture is not, there's no hope there. It is not going to fulfill the promise because they shouldn't be doing it that way anyway. So that's the way I look at it. I still think that there is a right problem set for microservices to solve. And as long as it is applied to that problem set, well, I think there is promise there. But the ground reality is, yeah, there are lots of bad implementations as well.
absolutely. Absolutely. I think it's the same with most technologies out there, right? You don't really go to a specific technology without understanding what is involved in implementing it. And the cost of microservices architecture in specific is very, very high, because you need to have a lot of standardization in place before you would want to go into microservices. While like one of the selling points of microservices is, hey, you have the flexibility of doing different things with different microservices, but that becomes unmanageable beyond a point. And that's where setting up all the infrastructure, setting up all the standardization, all that costs are maybe exorbitant for somebody like a startup who wants to really focus on a business problem rather than a technology challenge. Cool. Okay, so Kaushik, shall we start talking about the like some of the best practices and some of the challenges with respect to implementing microservices? Let's say there's a large enterprise which wants to implement microservices architectures. What do you think would be the most important challenges that they would encounter?
The most important challenge is to have a clear path towards what the final end goal is, right? So somebody's working on a monolithic system and they want to say, yeah, we want to make everything microservices, right? How do you go about it? How do you start? And also, when do you consider yourself done? Like, when is the transition to microservices done? That is not only overwhelming, that also kind of tends to trip people up. Some people will be like, yeah, this is too much, we don't want to get into this. Or some people have these grandiose plans of like, okay, here's how the perfect world will be, and they start going there, which is also a bad thing. What I usually recommend for people who are considering a switch to microservices is go at it a little gradually, right? So a lot of organizations can be, can work just fine with having a hybrid approach, right? Instead of a one big monolith, they can have a smaller monolith and some microservices, which is perfectly fine. There isn't like it's not a binary. Yes, are you using microservice architecture or not? Right? There's a spectrum there. So I think the biggest challenge is identifying what your end goal is, what your success criteria is, and getting there gradually, as opposed to saying, yeah, we're going to completely stop working on the monolith. We're going to create this brand new architecture with microservices with some big plans, because those plans, guess what? They're not going to sustain the first 6 months
Absolutely.
of your migration path. So you're going to have to constantly evolve. So, yeah, having that path would be the biggest challenge for somebody kind of thinking about starting their journey towards microservices.
Okay, so taking a step-by-step approach and searching for initial small wins where you can probably prototype your architecture. Shiva, any thoughts there?
Yeah, in my experience, most of the times where people go wrong with microservices is when they think about building a new system with microservices and all. Most of the teams, they focus on their part. Okay, we are so and so service. We don't care about the other services because we are this team. We don't care about the other teams and all. But from the customer point of view, though they don't care about whether you have a monolithic application, you have 20,000 microservices. They don't care about it. They care about, I did this action and I expect some kind of a output. That's what they care about. So here, if every team is only focused on what they are building only, they don't look at the grand picture, how all these pieces fit together. So maybe your application is doing fine, but if it doesn't align with the overall end-to-end process, and that's going to be a real challenge. Like your specific service is doing wonderful, but what
Absolutely.
happens if your service goes down? Is the entire ecosystem of your microservices setup is capable of handling that downtime? So that is what one needs to think about when we are going with the microservices. That's where most of the people, like, they start with a simple focus on individual microservices. They delay this concept of identifying whether if one component goes down, is our entire microservice setup is capable of handling it or not, at to the last. So then they start getting the surprises. Oh, we are not handling this scenario. We are not handling this concept. So that is where I see most of the challenges happening in microservices. So, and yeah, another thing is when we are designing microservices, in theory, we say it should be self-sufficient, and then you should be able to go to production independently, and even if it goes down, your system should survive. But the implementation is Many projects where I saw, they are kind of a very tightly coupled. They make REST API calls synchronously, and if one service is down, it cascades to all other services. Though you have all retries and everything is fine, but still, it is not fully created thinking one component goes down. Still, the application, overall application, should handle that scenario. So that is a very key concept to keep in mind instead of just
Perfect.
focusing on one service.
Yeah, I think like if you look at like one of the most important challenges with respect to microservices is, like, I think this is common irrespective of what you're breaking down, right? uh, if you have a large thing, if you want to break it down into smaller components, the question of how do you break it down, like how do you identify the boundaries, because that's what helps you to decide like how you would want to organize your application, or how do you want to organize your microservices. Shiva, any thoughts on the best practices related to how you would want to split up your microservices? How do you identify the boundaries?
Again, if you are following DDD, similar concepts apply here at the service level. Like in DDD, if you are applying DDD for a particular project, what you do first, you identify what are the bounded context, what are the service boundaries, right? So in a larger context, you have many subsystems. You identify the boundaries, and then within a single application, you treat them as a bounded context. If you apply the same concept at the overall system level, those bounded contexts may become a microservice, independent microservices. Um, the tricky part is if you go ahead aggressively and split everything that you can split into a separate boundary, later you may realize no, most of the times, whenever you want to perform some action, you want to talk to this service and this service. So that's an indication that you may have to club those things into a single component, single microservice. So that's a usually tricky part, splitting the big application into microservices. I would recommend go with a very gradual approach. Don't split into too many smaller components in the beginning. Identify large subsystems, and then over the time you get more and more understanding of the system. Then if you feel okay, this contains two different topics, but it is not really coupled together, then go ahead and split it. But splitting too many smaller things in the beginning itself is most likely is going to end up having a big rewrite again.
Absolutely, absolutely. There is a lot of cost that is associated with having too many small microservices as well. It's not like especially like for example, if I'm organizing an application and let's say I'm dividing it into multiple layers, probably the cost there is not as much as breaking it into different kinds of microservices, because each of the microservice needs to come up with its own setup, starting from like your source control to production, everything, and there is a lot of cost associated with it. So you should be cautious about how large the boundary is, but it's also like the chicken and egg problem, right? When you start off, you probably don't know what is the right boundary. Like you use something like bounded contest to kind of figure that out, but when do you implement that? All that is depending on the specific context, probably in the specific application, right? You need to take a lot of other factors into account as well. Kaushik, how do you think about it?
That's actually a good reason why we should approach this in a gradual manner. A lot of times I've seen people say, well, we're going to set aside the monolith, we're going to start from the scratch and create the idealistic world of microservices. And that's often bound to fail because you really don't know when you start out what those boundaries are. Bounded contexts are great, but then there are 10 different ways you can draw bounded context boundaries for the same business, right? So it's it's very hard. So I think getting into microservices requires you to understand that you may not get it right the first time. So start small, chunk away a monolith into smaller microservices, see how it works. There are some telltale signs, like Siva mentioned. If you have a change going into multiple services out, together, right? So to make any change, okay, I've got to deploy this service and this service, and that keeps happening often. That's probably time for you to go like, okay, should those two be together? Okay.
Mm.
And sometimes you have multiple teams making changes to the same service. Then again, that's that time for you to go, okay, should this be split? There is some amount of value you get in seeing how changes and business features are implemented, and what is the number of services or the number of different deploys that are affected by a certain feature. So I think a gradual approach and constantly pivoting and changing based on the need is what is a safer bet than like a big bang approach.
Cool. So, yeah, I think from the start, last 15-20 minutes, I think the discussion has been around taking a small step by step approach and not a big bang approach, because we don't really know what we are getting into when we start off with the microservices architecture. Cool. Like one of the best practices I found when we started implementing microservices architecture in enterprise we worked with was trying to standardize a few of the things at least. Like for example, one of the things which we standardized was the framework which we were building the microservices. Like the initial, like because we would be creating tens or maybe like hundreds of microservices over the long run, we found that creating an archetype of the microservice with which will be able to generate a microservice project quickly was one of the best practices which we can do to simplify the implementation of microservices architectures. Any other best practices you'd want to touch up? I mean, more on the technical side of things. Any other technical best practices that you can recommend with respect to microservices? Shall we start with Shiva?
Yeah, again, adding to your point of creating archetype, even in a couple of organizations that I work with, they also have a standardized process of having a template. In some organization, it is based on JHipster, which can create a production grade Spring Boot based application.
Right.
In some other application company, we have Maven archetypes. So the idea is most of the times you have some common things to be applied for every service, like some JSON-based logging, some monitoring aspects, like you have micrometer-based monitoring capabilities. So some of the things you may need to apply to most of the services. So usually what they do, they create a library, internal library or something like that, and then create an archetype based structure. So that will speed up creation of a new microservice. That's one thing to do to speed up the development. Another thing, most of the times you have to think very thoughtfully about the monitoring aspect of it when you are going to microservices. All other things are also important, but monitoring takes the cake. Like without monitoring, good monitoring support, it's going to be a hell. You don't know what is going wrong and where it is going wrong, and only
Absolutely.
end user is going to say it is not working. They are not going to say where exactly which component is not working. So without having any of these monitoring capabilities, like be it logging or other monitoring support like Datadog or something like that, it's very difficult to identify. So if you are thinking of going with the microservices, think about this automation of having monitoring, logging, centralized logging. These are really, really essential. They are not nice to have. They are really essential tools. And apart from it, there is usual things like service discovery, centralized configuration management, and all those things. But again, earlier we used to, in Java world, we used to have all Spring Cloud config server, service registry, Eureka, and all those stuff. But I see in the recent Kubernetes world, they become not so relevant because Kubernetes itself provides most of those capabilities, service discovery, config,
Absolutely.
and all those things. There is a big overlap, and most of the features are also provided by Kubernetes. But these things we need to take into account. If you are not onto Kubernetes, you need to think about this centralized configuration management, service discovery, and then these retry mechanisms and what do you call? I forgot the name. There is this resiliency fuzzy library to tackle
Right.
these scenarios, right? So we need to keep in mind these things because you are splitting one big application into so many smaller things, and there will be a lot of traffic from one service to another service. So you need to
Right.
really think about what used to be a simple another method call in the same JVM now is a HTTP call to a completely separate service. So that
Absolutely.
it should be thoroughly thought through, and then put all these circuit breakers and all these concepts.
Absolutely, absolutely. So instead of a single call to a microservice, I mean, instead of one call, you are breaking up the call across multiple microservices. So you would want to understand what's happening behind the scenes, and whenever you would want to find a problem, you might want a lot of tracing across the microservices. You might want logs, centralized logs, where you can search across the logs from multiple microservices, and also look at metrics related to all these microservices as well. So as you say, Shiva, I think microservices, like observability of the microservices, is very, very important. Kaushik, you have anything to add there?
No, I agree with everything that Siva mentioned. It's basically taking everything that you did for a monolith and doing that 10 times over or 20 times over, or sometimes even like 100 times over for each service. So
Right.
having a template like a Maven artifact, archetype, or just these starting points that you can quickly clone and create microservices out of is definitely useful. The one trap that you need to be aware of is do not share things across microservices. There is a certain benefit you get from having the same thing repeat in each microservice. So you get like, okay, you've established best practice that shows up in all microservices. Great, you've replicated that best practice across services. But if you have like a library and you're using that library in your archetype, now every microservice of yours is using that same library. So you now have some kind of a coupling as a result of you saying, I'm going to create this kind of like cookie cutter templates out of which microservices are created. So you need to be careful about the implicit coupling that could be possible in creating these templates. As long as you're not coupling these together to a single dependency, I think having an archetype is a great way of replicating your best practices across services.
Awesome, awesome. So what you're referring to, like, you would have a lot of common things like authorization, authentication. Those things can be common, but whenever you make something common, you need to put a lot of thought behind it. Is that the way you?
Right. Yeah. Yeah. That's kind of what I meant. Having something common is okay as long as it's a deliberate choice. I have seen
Absolutely.
people where it's like, yeah, this microservice is already there, now I'm going to create another microservice exactly like it, and now they share some libraries, and now you cannot make a change to the library without affecting both microservices. It's kind of like you can fall into that a few traps there if you're not being careful. So that's what I was
Absolutely,
referring to.
absolutely.
Yeah.
You don't want to just share business logic between two microservices using a common component, for
Right.
example.
Yeah.
Then the business logic is now living in two places.
Yeah.
Awesome, awesome, cool, right? I mean, one of the aspects that Shiva was touching about was Kubernetes, right? So the evolution of containers, container orchestration, that has played a huge impact in the evolution of microservices architectures. Actually, technology in general, I would say, right? So when we started off, probably like in the Java world, when we started off, the most popular framework to implement microservices was Spring Boot, like, and Spring Cloud provided a lot of technology related features which were needed with respect to implementing microservices, like cloud config server, API gateways, and a lot of other features that we would need. So there were different projects that were part of Spring Cloud, which were providing a lot of different features which help you to get started with setting up a microservices architecture very, very quickly. And off late, like Shiva was saying, like we are now moving into the container and container orchestration world. One of the aspects where containers really, really help is standardization, right? You might be having microservices in Java, Python, or different languages. Again, it has to be deliberate choice that you have multiple languages. A lot of times, you might want to actually stick with one language, but like containers bring you standardization across multiple like all the microservices, so that you can have the same process to deploy them, observe them, and the entire process becomes standardized. Kaushik, do you want to elaborate on that evolution, like towards containers and container orchestration?
Yeah, I think Kubernetes is one of the things that kind of got to this evolution. I think the evolution kind of started with Docker itself. Docker was one of the primary enablers of having these lightweight microservices, because now you could have reproducible runtime environments that you can just create like 10 or 20 off, right? So starting from there, moving on to container orchestration, orchestration took over a few of the responsibilities that you would have otherwise had to do on your own. Like, for example, service discovery, right? So with Kubernetes, you don't really need to have another framework for service discovery. You can kind of use the native thought process behind Kubernetes itself to discover where you have deployed your containers. So stuff like that has been transformative. But the thing about Kubernetes also is that there isn't really one way of doing things. Different people, people tend to be very opinionated with Kubernetes. I don't know if you folks have encountered that as well. So there isn't really like a good best practice way of doing things. Different companies tend to do it differently. But I think as far as enabler is concerned, yes, Docker and Kubernetes have revolutionized the microservices world in terms of reproducible environments, as well as how you can scale it and deploy it to the cloud without having to worry about a lot of the underlying details.
Absolutely. I mean, to take your question on like the variety of options that are present with Kubernetes, and different enterprises go in different directions. I think one of the major factors there is the fact that Kubernetes itself is very, very young, right? I mean, we are talking about 5 years max. And it's like there are so many changes in Kubernetes. I mean, not the core of Kubernetes, but around in the Kubernetes ecosystem, if we can call that. There are so many changes in how probably you do monitoring with Kubernetes. Even things like as simple as how do you do continuous delivery with Kubernetes, that has undergone a significant shift in the last few years. Like the thought process a few years back was more like a push mechanism. Now, like there are people debating whether it should be a push or a pull kind of. So there are wide variety of arguments there as well. Shiva, thoughts?
Yeah. So coming to the standardization, I know a couple of organizations where they standardized on Kubernetes platform so well, where all you have to say is what is your image name, Docker image name, and then specify your app requirements, like my app needs so and so memory, so and so CPU. That's all you have to say to the DevOps team, and they take care of everything else. So they standardize all this. How do you configure things, and how do you maintain secrets? How do you maintain resource limits, and all that they standardized into a kind of a Helm charts. Yeah, they are very standardized, but it becomes mature over the time. Like Koushik mentioned, it's there are so many ways to do the same thing, and different people try different ways, and then probably over the time they identify the pattern. Okay, we are doing this; it's not right way, and then okay, this worked well in that project. Maybe we can try out that. So like that, within an organization, this standardization evolve over the time. um, yeah, but I see a good adoption of Kubernetes standardization in few organizations. They are really good.
Absolutely. Absolutely. When I actually started off, my microservices course just had Spring Boot and Spring Cloud. And 2 years back, I realized microservices without containers and container orchestration does not make sense anymore. And therefore, I had to actually re record the entire course, adding in Docker, Kubernetes, and making them kind of the central part of the whole thing. So it's quite an evolution with Docker and Kubernetes. And today, also another factor which is playing a crucial role with respect to, I think, everything that's happening in the technology world is the cloud, right? So you'd see that earlier one of the biggest challenges with running Kubernetes what was setting it up in a reliable way, and like having a cluster, a reliable Kubernetes cluster like in place was a very, very big challenge. And now I think with almost every cloud provider providing Kubernetes managed implementations, it's becoming much more easier to adopt Kubernetes as well. Just to go on a tangent a little bit, another technology, another buzzword technology, whatever you call it, which became really, really popular a few years back, was serverless. Right, everywhere we go we see serverless, like whether we're talking about serverless compute, serverless databases. So a lot of places we were talking about serverless. And Kaushik, did you see any impact with respect to serverless compute, right? I mean, when we talk about serverless, I think it's a big boundary, because databases or a lot of other things come into picture. And also, even when we talk about compute itself, there are a variety of serverless computes, right? One is a function which can be independent. Another thing is compute, like containers. For example, if you create a container, you can use a service to run it in a in a serverless kind of a way. There are many services to be able to run containers in a serverless way. So let's start with probably discussing about the functions aspect of it, right? AWS Lambda, for example, or cloud functions, right? So did you see any impact on the serverless functions with respect to microservices?
Honestly, this might be a controversial opinion. I feel like serverless only applies to serverless functions. Once you get into containers and all that stuff, it's not quite serverless, at least not the initial
Okay.
promise of serverless. So,
Okay.
in my mind, serverless is basically when you have, just supply something, a function like AWS Lambda, give it a function, it is going to execute it, and you're going to get charged for the execution of the function and not so much the resource uptime. Here's my opinion about serverless in general. I think the biggest draw, the biggest attraction for serverless was primarily the cost. Okay, if you think about, like, okay, if I have, like, unlimited money, right? Hypothetical situation, unlimited money.
Mm.
Would you do like a containerized workload, or would you create a Lambda function? I would probably prefer a containerized workload, because it's easier for me to just keep it there, and then I don't have to tie myself to a specific serverless function implementation. Like, I don't have to write a Lambda in AWS Lambda, and then, okay, you can technically wrap it around and then make sure it's portable, but still there is some amount of coupling there. Might as well create like a Docker container which runs a process. So the main reason I would do serverless was the cost. Now, the thing about the cost is, I've talked to people who have said, well, yeah, we started out serverless because the cost, it's cheaper than running a server all the time. But then there is a certain tipping point where you have enough serverless calls that at that point it becomes like, yeah, we might as well run a full a server, like,
Right.
have a process that's running all the time, and not have it be this serverless thing, because you end up saving more. Now, considering that the whole promise of serverless was the cost, there is a certain tipping point where you have to be careful and say, okay, if the function is sparingly used, or I don't have like a consistent workload, then go with serverless. If not, you would use something a little more stable. There were some initial concerns about the startup time, right,
Mm.
for a serverless
Cold
function to
starts.
warm up. But a lot of cloud providers have done a lot of good work there, including some people writing their own JVMs to make sure that the startup time is more efficient. So a lot of
Right.
work has gone there. I don't see that as a concern. But in my experience, I haven't seen a lot of serverless adoption for microservice architecture. It's more of like, unpredictable workloads, one-off things that people tend to go with serverless. I don't know if your
Absolutely.
experience has been different with this, Shiva.
Actually, I have very minimal experience with serverless workloads. Only sometimes we get some events like some other systems, they upload some file into S3 bucket and we have to take care of this. So these kind of one-off tasks, only those scenarios we have used serverless. But I have seen some clients where they implemented their entire application as a serverless functions, and then they start complaining that it is very slow, and obviously it will be slow. You are spinning up a whole application when you get a request, and then they go ahead and start implementing all these cold start, hard start, whatever tactics. And then I don't know how this billing works in that scenario. Like, if you have some cold start where you already run something, so how different it is than running a server all the times. I don't know the billing part of it, but in general, these are more like a specific scenarios that you can apply to, but trying to apply these tactics for the entire application architecture, I don't know how well it plays with the whole system. Yeah.
Cool. Yeah, Shiva. I think that's exactly what I observed as well when I talked to a lot of people. Earlier, I mean, a couple of years back, I would say serverless was in big competition with Kubernetes because a lot of people used to think breaking breaking things even further to a small scale, right? With microservices, we said, okay, I can break down thousand, like a big 1,000 part component into 1,000 different parts. Now I'm saying with cloud functions or like Lambda that I can break even each of the part into sub components with individual release cycles and things like that. However, people realize, I think, those two problems, right? One is cost, second is performance with respect to cold starts. And as you say, Shiva, like cold starts is a very, very like if you want to avoid cold starts, as you say, you have to have a certain number of things running all the time, and that's almost very, very similar to having your containers running all the time. So you are going back to the earlier problem of uh, like now like solutions are around using machine learning to find out to predict the workloads. So it's all something which I can also do with containers as well. It's not something which is specific to Lambda as such. And the biggest challenge I see when I talk around with people is maintainability aspect, because earlier we had maybe like 10 moving parts. Now with cloud functions the moving parts are even higher. So I guess like my experience also resonates with your experience. It's now more places where you have events which are being triggered and you would want to handle specific events. That's where you tend to go with microservices architectures. You have an object storage like cloud storage, or you have S3 where some event happens, you want to quickly respond to it. That's kind of the places where I see like the serverless I mean, with respect to functions coming into picture, right? With respect to containers and all that, it's a completely different equation because we are going back to containers, right? If you like Google want, like almost everybody, every cloud provider wants to sell everything as serverless today, right? They want to sell every compute, every database as a serverless thing. However, like the as Koushik was saying, it's the original. If we go back to the original intent of serverless, which is respect to just the functions part of it, I think the adoption of it is not as far as I expected a few years back. Actually, even I invested a significant amount of time on serverless, understanding it, and also creating courses around it. But hardly there is any traction with respect to those courses as well. So I mean, that's also a reflection, maybe with the fact that it's not doing as well.
I
Cool.
think there is a certain workload where serverless functions make sense. That is when you have this unpredictable need to super scale compute, right? Compute bursts is a good way to look at it, right? So you have uh, at some point of time you want to, like, let's say real-time analytics, right? That's one use case. So you have a data lake or something like that, some structured data farm, and there is a request for some analytics where there is a lot of immediate number crunching that you have to do, right? Somebody runs a query and you have to do number crunching, like get as much compute as possible, just
Right.
get that number crunched and then respond. So for that, a serverless function is ideal because now you don't have, like, imagine how you would do it without serverless, right? So you would have to, um, you know, estimate what is the capacity and then plan
Right.
for the best capacity that you need. But now here you can basically have these, as long as the compute is kind of map reducible, you can basically split out the work into multiple different stateless functions and then gather it
Absolutely.
together and return a response like as soon as possible. That's a great use case for serverless functions. But as you can imagine, that's not very common. It's an off, once in a while you get those use cases. So maybe perhaps for those use cases, think serverless. But otherwise, just for saving cost, I don't think there is a significant value with serverless
Absolutely.
functions today, in my
Yeah,
opinion.
and add to it is the fact that cloud providers are also innovating with respect to the things you're talking about, Kaushik. Like, for example, BigQuery, for example, right? You run a query, you don't really worry about what's happening in the background. It can like probably divide the computation of like it would probably like one of the biggest things that BigQuery does, it separates out compute and storage. So you might be storing like huge amounts of data, but the compute is not tied to that, so you don't really need to pay huge amount for the compute. And whenever you'd want to trigger off something which is very, very complex, like let's say I would want to run a SQL query across 100 tables in BigQuery, like it's able to fire up the necessary compute and fire it down as soon as the query execution ends. And I guess that's what a lot of cloud providers are doing. Like wherever there are specific use cases where this kind of thing is really needed, they are able to provide managed services around that. And probably I think that's where the evolution of containers, like for example, I'm more familiar with Google Cloud, so Cloud Run is one service. Like instead of, like, why do you need to really launch up, like why does a function need to be the building block? Why cannot the container be the building block and still enable every promise that was intended behind the serverless uh, like initial promise, right? So I think cloud providers, because they have a lot of money, they can invest and kind of bring serverless not just based on the functions but also make a lot of other things serverless. And that's where probably the word serverless becomes really confusing these days, right? The original intent was something, now we talk about something else as serverless as well. Cool, cool.
Yeah, I think
um,
that containerized serverless is basically a way for you to expand the scope of the function to the environment as well, right? Considering that a container is basically just a jailed process, right? So when you think about serverless, what are you doing? You're starting a process that executes a function. Now, if you were to do that in a container context, you basically have a jailed process which executes your serverless function, but now you have more control over the surrounding aspects to it. So if you think about it, like, why would you not want that, right? There are like, if you don't have a need for controlling your environment, fine, just have a use an Alpine container or whatever, like just bare bones container, and then run
absolutely.
with it. So I think the concerns are kind of the same in a way, but again, like, if you have a good use case for serverless, then all these come into the picture. But yeah, like we've been talking about, the use case itself are few and far between. So that's a little tricky.
Absolutely, absolutely. Yeah, I think it's been an interesting discussion. We started with some of the challenges which enterprises are facing with respect to implementing microservices. After that, we talked about the role of containers, container orchestration, serverless in the evolution of microservices. Any other topics that you'd want to touch upon, Shiva, Kaushik? It's open for you now.
So there are these custom distributions of Kubernetes, right? Like Red Hat's OpenShift and then Tanzu. So did you see adoption of those things and then leveraging those additional features of those Kubernetes distributions? So what I see, one of the reason people go to Kubernetes is these days most of their applications are running on cloud, and to be on safer side, to not completely lock down with a particular cloud provider, you can run your containers using ECS, but you tie to AWS, right? So to avoid that vendor lock-in, they choose Kubernetes. So if for some reason if they want to switch to Azure or something like that, it's relatively simple. So, but again, when these Redshift or OpenShift or Tanzu, so do you see again going back into that vendor lock-in, or how minimal that impact is?
Yeah, I think with respect to Tanzu and OpenShift, the question is whether you'd want to go for a private cloud. I mean, there's also question element of private cloud versus public cloud in there, right? A lot of enterprises, like for example, banks, are really, really conscious about running workloads in the cloud. So, like what Tanzu and Kubernetes, I mean, OpenShift allows you to do is to also create your own private infrastructure to run Kubernetes. So it's kind of you get some of the benefits of the cloud. Obviously, it's not as flexible as the cloud itself, but you get some of the benefits of the cloud, and still you don't really need to worry about managing your Kubernetes cluster, right? You have a layer on top of it, like either Tanzu or OpenShift, which takes care of it. And also, like one of the other things is these, like for example, today, like if you talk about Kubernetes, like Anthos is also a way you can run multi-cloud Kubernetes, right? You can use Anthos at the top, manage Kubernetes clusters which are in different clouds as well as in your data center. But even before Anthos, like OpenShift was already providing you that. So with OpenShift or with Tanzu, you'd be able to actually have your infrastructure in the cloud, but it's managed from Tanzu. Therefore, it's much more easier to shift from one cloud to another. One of the biggest disadvantages, or actually one of the biggest challenges with going for a cloud specific Kubernetes implementation, is that you are not just making use of Kubernetes, right? Kubernetes is just one part of the entire ecosystem, and then you tie yourself up with a lot of elements with that specific cloud provider. And even though I would say I can shift my Kubernetes workloads, there are a lot of other things which you have to get in place before you'll be able to move the entire application off. And that's where like these have a role to play. For example, Tanzu is like, because you don't have any way you can directly tie up with a cloud provider, you are restricted, your boundary is restricted, therefore you are much more cloud neutral in that way.
So another aspect I want to have a discussion around this. Before this microservices, one of the similar topic was service-oriented architecture. And now when we discuss about service-oriented SOA versus microservices, SOA is more towards centralization, where governance and everything happens in a centralized manner, whereas microservices is mostly decentralized. Every service takes care of itself alone. But in the recent times, you think of Istio, right? You are taking away all that common parts of it, like circuit breaker, all these timeouts and everything, and again you are putting in a centralized place like in Istio, right? I don't know exactly. Like again, in an indirect way, you are leaning towards the centralized management mode, but still each microservice does its own thing, but there is now a centralized place where you are controlling all these aspects. But again, this is not truly centralized like ESB or something like that. uh, yeah, I am not really that familiar with Istio, but I have this thought of what exactly is going on. Is it again we are going into the centralized management mode or something?
I
My
think.
thoughts. Go ahead, Koushik.
Oh, sure. Sorry. Yeah. So I think that again, as with anything, there are good ways and bad ways to do a service mesh. If you The ideal way to do it would be to earlier in this discussion we were talking about identifying the common concerns and then making like an archetype out of it so that we kind of have this prototype for different services, right? The way I think about service mesh is a kind of a runtime prototype of these concerns, which are not business specific, which are more of like things that you would have to do for a business, right? If you're doing like fault tolerance or distributed monitoring or distributed logging or stuff like that, those kind of concerns are moving to a service mesh, then yes, you're doing it supposedly the right way. But if you are having something related to the business, this is one of the reasons why the enterprise service bus failed, right? Because they were kind of like these gatekeepers for when a schema in a global namespace had to be changed, or when there are two different things which need to communicate with each other. You can't have those two teams go and do those changes in isolation. There has to be this kind of like a global committee who is overseeing everything, that has to approve how two different services talk to each other, right? Those ideally should not be in the scope of the service mesh. It's more of like these common kind of nuts and bolts for all microservices. At least that's the way I look at it. So I don't see that as a problem in terms of centralizing these things. But yeah, there is always a chance of you not doing service mesh the right way, and you end up with these kind of coupling concerns, which is not a good place to be in. Sorry, Ranga, please go ahead.
No, I agree. I mean, I echo your thoughts,
Yeah.
Kaushik. Business logic is not the thing you'd want to implement in a service mesh. If you look at ESBs, what we were implementing there was the business logic. How do you want to do aggregation? How do you want two services to communicate with each other? Right. So there was a lot of business logic which was in the ESB, which is not what you want to go into a service mesh or Istio. Right. Istio is more responsible for the technology part of things, authentication, authorization, like observability. Those are the aspects you'd want to have your service mesh implement.
Yeah. So it is mostly taking the technical concerns, not at all business specific things.
Right.
Absolutely, absolutely. And it should be the same Istio component Ideally, you would have the same component deployed with all the microservices. So it's not a customized Istio component for a specific uh, microservice.
There are also some thought process around, like, if you want different technical concerns for different microservices, it has to be in the configurability part of the microservice itself, and not so much kind of like a conditional behavior of the service mesh. It's like any configuration has to be driven by the service and not by the service mesh. That also makes sure that you don't have like the centralized thing which is dictating stuff. It's the microservice which is like, we have to do configuration for microservices, make it the 12 factor way. So all the interactions, the variability in terms of how the service mesh works with the service is also controlled by the service itself. So that also encourages autonomy in services.
Awesome. Any other aspects related to microservices that we want to touch upon, Koushik? Anything that you have?
I think there is an interesting trend towards event-driven microservices, which is really an interesting approach to solving some of the problems with microservices. I am not really an expert with that. I have played around with it, and I see that while it solves some problems, it introduces some other problems. So there are patterns around how you make things event-driven and how you kind of identify state in an event-driven architecture, because compared to an architecture where all microservices write to the database, is like the single source of truth. With event-driven architecture, events are everywhere, so data is all over the place, right? Data is in moving. We talk about events in motion, events in rest, and a whole lot of concepts there, right? So if you want to know at any given point of time, okay, what is the balance for this single account? Well, you can't go look at one place and find out, right? Maybe there is an event in along the way which has updated the balance. So it's like a whole new set of challenges involved there. I think the industry is not mature enough when it comes to event-driven architectures, but it's a very interesting space to kind of keep an eye out for in the future.
Yeah. Another term I frequently heard with respect to microservices was the concept of event sourcing. Have
Yeah.
you heard about it? Okay. Okay.
Actually,
Cool.
nothing. It is nothing specific to microservice. Even a monolithic can implement event sourcing, but
Mhm.
I would restrict that concept to a specific use case, just like serverless. It is. I see some people are suggesting to go full on event sourcing. That's a terrible idea, in my opinion. It should be
Okay.
it should be used cautiously for specific scenarios. There are a lot of trade-offs when it comes to event sourcing. Uh, yeah, I think we can talk about this event sourcing and event-driven architecture. They deserve an entire episode on its own.
Perfect. Perfect. Nice to have you here, Kaushik and Shiva. It's been really, really good to kind of have a conversation with both of you almost every week on various kind of topics. I think it's been like almost like 7 8 sessions that we had until now, and it's been wonderful. Like it's really, really uh, like great that you are able to take the time out of your busy schedules and spend time to share with the audience your experiences with respect to different things. Thanks a lot, Kaushik. Thanks a lot, Shiva.
Thank you.
Thanks to share and learn. Yeah.
Thank you. Do not forget to subscribe. Go ahead. I'm waiting. Thank you. Keep learning every day. Keep learning in 28 minutes.